Hi, everyone, and welcome to part one of chapter 3 in Psych 3510. This chapter is titled Three Claims for Validities Interrogation Tools for Consumers of Research. So, what this chapter is all about is introducing us to the three types of research claims that can be made, some of the sort of foundational elements of experiments and research, like variables and constants. And then we're going to discuss the four validities, which are ways in which we critique a claim. So if someone were to make a claim about the world, they can make one of three types of claims. We'll go over what those are. And then we can critique their claim by applying four validities. You can think of validities as tools that we use to help us understand whether a claim is a legitimate or a good or a strong claim, or whether a claim can be dismissed or it's perhaps a weak claim. Okay, so first we're going to talk about variables, and then we're going to define our three claims. That's probably as far as we'll get in part one. And then in part two, we'll discuss how we interrogate those claims with our validities, and then we will discuss prioritizing validities, because sometimes certain validities might be more important than other validities, depending on our goals. Okay, so you can't have research or an experiment without variables. And we can contrast variables with what are known as constants. So variables are measurements of the world that can vary, right? That might be different from person to person. Whatever we're measuring, however we're defining it and measuring it, it's something that can change from person to person. Versus a constant, which is often something that we intentionally hold constant in a research study or experiment. It's something on purpose that we control so that it does not vary. Here's an example. We have a research question below. Do seniors from public high schools perform better or worse on the SAT than seniors from private high schools? That's our research question. Perfectly legitimate educational research question. Maybe you're investigating how public versus private schools prepare their students for college. Maybe you're investigating something like how wealth or income impacts educational performance. Right? Presumably, children in private schools come from wealthier families. So, public schools versus private school seniors, and we're comparing them on SAT. So there are two variables in this study. The most obvious one is SAT score. That's going to change from student to student, right? Some students will score low, some will score average, some will score high. So that's a variable. It's something in our study that we expect to vary, and we are going to measure that variation. Another type of variable in this case is type of school. This is what we call a categorical variable. It puts people into distinct groups or categories. So we have the public high school group, and then we have the private high school group. And that varies from person to person, right? Our participants will vary along which group they are in. And we have at least one constant here that we can tell from this description, and that's grade level, right? We're only looking at seniors. That's a decision that was made by the researchers for some, either practical or theoretical reason. They're only interested in how seniors do. They're not interested in anyone else, freshmen, sophomore, juniors. They are holding grade level constant in the study. So let's take a second and look at another research question. This one's slightly more complicated. And what I want you to do is read this prompt and then pause the video and take a few minutes to try and see if you can list out the variables in this study and then list out any constants that you see in this study. So here's the prompt. I'm interested in what predicts marriage satisfaction in newlyweds, people who've been married within the last 2 years. That's how I'm defining newlyweds. I collect data to see if personality trait combinations predict marriage satisfaction with 200 newlywed couples. So if one partner has these personality traits and the other partner has these personality traits, does the combination of personality traits predict marriage satisfaction in newlyweds? But I also ask if this personality trait impact differs based on heterosexual or same-sex couples. So, do personality trait combinations predict marriage satisfaction in newlyweds, and does that differ based on whether you are in a heterosexual or a same-sex relationship? So go ahead and press pause, take a minute, see if you can define the variables and any constants, and then click play, and I'll talk through it with you. Okay, hopefully you've done that. Let's start with variables. So what are the things that are going to change from person to person here? Personality traits are going to change from person to person, right? Presumably we are going to be measuring personality traits in our couples, and people are going to differ on their personality traits. So that's one variable. Marriage satisfaction is our second variable because some couples are going to be more or less satisfied with their marriage. Our third variable is the nature of the relationship, whether it is heterosexual or same sex, right? That's couples are going to fall into one of those two categories. And that's it for variables. We have personality traits, we have marriage satisfaction, and we have sexual orientation, I guess is what we could call it. Now, constants. I believe we only have one constant, and that is the amount of time that people have been married, right? We're only looking at newlyweds. We have defined newlyweds as people married within the last 2 years, and we're holding that constant. Everyone in the study is a newlywed. We're not looking at long-term marriages. We're not looking at people that have been married 10, 15, 20, 30, 40 years. Only newlyweds. So we are controlling that for, in this case, probably theoretical reasons. We probably think that young marriages, right, newlyweds, are different from long-term marriages. And so we want to only study newlywed couples. Now, when we're talking about variables, we can further define the category of variables into measured variables and manipulated variables. Measured versus manipulated. Pretty simple here. Our measured variables are observed and recorded, right? We measure them, but we don't control them in the environment, in the world. Versus a manipulated variable, which is one that the researcher actively manipulates and controls such that we assign certain people maybe to one condition or experimental condition, and then we assign other people to a different experimental condition. So if I was studying, just a nice easy example is weight loss. So I want to study weight loss. Number of pounds lost, or we could maybe call weight, would be a measured variable, right? I can't actively manipulate someone's weight. That's the outcome that I'm interested in, right? That's what I want to measure. But then what I could do is maybe manipulate diet. Maybe I could manipulate exercise. I have half of my people doing cardiovascular exercise, right? They're running, they're biking. And then I have my other half of participants only doing strength training, right? They're lifting weights. And my research question is, does cardio versus strength training differ in the amount of weight loss that I will see? So weight loss is something I'm measuring, but I manipulate the variable of type of exercise, right? I control it. I force half of my people to do cardio, and I force the other half to do strength training. Now, um, be careful not to get a manipulated variable confused with a constant. Right? A constant is also something I control, but it's something that is constant across the experiment. That means people do not differ on it. If something is a constant, then people don't differ, like the newlyweds. Uh, Whereas if I create two categories, one for strength training and one for cardio, and I force people into one of those categories, I'm manipulating I'm manipulating the world, right? I'm controlling something about the world, and I'm creating a variable because people will vary based upon whether they are in the strength training or they are in the cardio group. Let's keep in mind that some variables can only be measured variables. So you can think of these as like person level variables. I can't manipulate someone's age. I can't manipulate someone's race. I can't manipulate someone's sexual orientation, something like that, right? These person level variables tend to be things that can only be measured. Versus other variables that can be either manipulated or measured. So let's look at a few different variables and let's talk about whether they're measured, manipulated, and then sort of dig into them a little more in a little more detail. So over here on the left, we have our variables. Let's say our first variable is car ownership. So what I need to do is what's known as operationally define car ownership. So basically, how do I take the idea of car ownership and turn it into data? Right? Turn it into a response from the participant. This seems pretty simple, but it actually is not. This can be very difficult to do in a accurate way. So, for example, I could ask people, do you own a car? Yes or no, right? I own a car. I do not own a car. Seems really straightforward and simple, right? That's how I could operationally define it. But let's keep in mind that someone's response to that question is not necessarily the idea of car ownership, right? You could imagine someone saying, yes, I own a car, when in fact, maybe they lease the car, right? Because what they take the question, do you own a car? They take that to mean, do you possess a car, right? Do you have a car that you use and you call yours? But having a car is very different from owning a car, right? Owning means you own the asset. Your name is on, the registration, so to speak, and the actual physical ownership of the car. When you lease a car, the dealership owns the car. You're just paying them to use the car, right? You're basically renting the car from them. Or someone could answer yes to this question when in fact maybe their parents own the car, right? Or their significant other is the actual person who owns the car. They do not actually own the car. So something that seems really straightforward can be difficult to operationalize. We could, instead of asking people this question, we could go, look it up in maybe a database of registered vehicles from the state or something like that, right? That would be the exact way to measure car ownership. But because that's too difficult, maybe we don't have access to that database, we're just going to go with the question, do you own a car, yes or no? This produces what we call two levels of the variable. Think about levels as different options. What are the possible options within the variable? So Uh, there are two levels to this variable. You either own a car or you do not, right? Option one, option two. We have two levels. This variable is measured because I cannot manipulate who owns a car or not, right? In the context of this experiment, I'm simply assessing the behavior that's already occurring in the world. Our second example, expressing gratitude to a romantic partner. I need to define that. I need to operationalize it somehow. And so maybe I do it in a question like, I tell my partner often that he or she is the best, right? That they I feel gratitude about them, right? That they're the best. So people get this question and then they have to rate from 1 to 7. That's actually called a Likert scale, Likert. I see these all the time in rating systems. If you ever get an email asking you to rate a hotel that you just stayed at, or when you order food on like Uber Eats or DoorDash, right, and you give someone 5 stars or 4 stars, right? That's what's happening here, right? From 1 to 7, you either strongly disagree to strongly agree with the statement. I tell my partner often that he, she is the best. So we have operationally defined it with a specific question. We have 7 levels, right? There are 7 options. 1, 2, 3, 4, 5, 6, 7. And this is a measured variable. Now, our third example is going to be a manipulated variable. Maybe we're interested in understanding people's perception of scientists, right? Or perception of science in general. And so we have participants read stories about Albert Einstein or Marie Curie. If you don't know who Marie Curie is, she is, I believe, the only woman to have 2 Nobel Prizes. She won one in physics and one in chemistry. She along with her husband are responsible for discovering like radioactive isotopes. And not surprisingly, she ended up dying of cancer from the radiation. She literally gave her life to the science. But this was before we knew that it was dangerous, right? This is a long time ago. Anyway, participants are going to read stories about Albert Einstein or Marie Curie, but what the researchers do is half of the participants read about the struggles of the scientist, and half of the participants read about the achievements of the scientists. So what we've done is we've split our participants in half. We've created 2 groups that we have manipulated, right? Because we force half of them to read about achievements and we force half of them to read about struggles. So we have 2 levels, struggles versus achievements, and we have actively manipulated this variable. So let's talk for a minute about operationalizing variables. Let's take the example of school achievement. School achievement is what we're interested in understanding. That is the conceptual variable. Right? School achievement is just an idea. It's a concept. There are many ways that you could measure or define school achievement. That would be an operationalization of the variable. So we're interested in the idea of school achievement. We could ask people what grades they get in a self-report questionnaire. Do you get all A's, mostly A's and B's, B's and C's, right? We could check their records and get their exact GPA, for example. Or we could ask teachers to make ratings based on their observations of the students. Notice that all 3 of these are perfectly reasonable, perfectly legitimate ways to measure school achievement. They are all, however, going to have pros and cons. So I think the self-report questionnaire, the cons are pretty obvious. People can lie, or people can maybe not knowingly lie, but maybe people are unaware of what their true grades are, right? You maybe tend to sort of unconsciously or subconsciously inflate your own self-worth. And so you pick the mostly A's and B's when in fact you don't really get that many A's. You get the occasional A, but really you get B's, right? That's mostly what you get. So you're opening yourself up to either the participants lying to you on self-report questionnaires or being biased, right? And not understanding their own bias. However, the advantage here is that we can collect lots of data very, very easily, right? I could spam this out to 10,000 Georgia State students, and I could get a bunch of responses and a lot of data in a very short amount of time. Next would be something maybe a little more concrete, like checking actual GPA records with the university. This provides pinpoint accuracy, right? We know exactly your GPA is 3.41, right? And that person's GPA is 2.85, right? We have incredible specificity if we do it this way. However, this is probably time consuming. We may or may not have access to this database, to these records. We might have to jump through a lot of hoops and get lots of different approvals from different levels of the university. And there might be some things that we have to do in order to get access to this that are difficult or time consuming. We might have to pay, right? Because it's going to take time and effort for someone to cull through all this data. So Georgia State might tell you as the researcher, sure, but that's going to cost us like $1,000 in work hours to get someone to do this. We need you to pay us for that. So again, the pro here is really fine-grained specificity in the data, but this might be a little difficult or impractical to get a hold of. And lastly, our teacher observations. There are numerous advantages to this. Student performance on exams or graded material might not perfectly reflect their actual performance in the classroom. Students might have test anxiety. They might have disability accommodations. They might do poorly on exams, even though they understand the material, right? That's possible. And so a teacher observation might capture some of that stuff that's not captured in the exam, right? A teacher observation could capture things like effort or cooperation, where checking your GPA can't capture that. Of course, observations are problematic because teachers can be biased themselves, and this is going to be time consuming. It's going to take a lot of time and effort to work with teachers on producing these observations. So as we move from our conceptual variable, we have to make a pro-con choice about how to operationalize any variable in the world that we're going to try and define. There is always a cost to making one choice over another choice, and you just have to live with the cost, and you have to make the choice that suits your needs and desires as the researcher the best. But there will always be a cost. Now, it's possible that you could do multiples of these, right? You could do all three. Why not? Again, it's more time consuming. It's more effort. It's maybe more costly. Nothing says that you have to only measure it one way. You could choose two of these. You could choose all three. You could come up with something else that might be a perfectly legitimate operationalization. But again, for every choice you make, there are going to be pros and there are going to be cons. We just have to be aware of what those are. So in general, in the world of psychology, we can define operationalizations as coming from one of three types. And here we're going to shift and use the example well-being, right? Maybe psychological well-being or physical well-being or emotional well-being, right? Whatever it is. there are three main categories of operationalizations. Self-report, so just asking the person, here, take this 15-item questionnaire about your well-being. Straightforward. The second general category is observations. So maybe we bring people into the lab and we have them doing all sorts of different activities, and we're videotaping them, and we count up the number of times they smile across our 2-hour session in the lab. We observe their behavior, we quantify their behavior, and then we define our variable based on those observations. And lastly, in the world of psychology and behavioral science, we can have physiological measures. So if I'm interested in well-being, maybe I measure your HPA axis activation, right? I can measure hormone levels, I can measure blood pressure, I can measure heart rate, I can measure cortisol, which is like a stress hormone. I can measure all kinds of physiological things to try and sort of tap into this idea of well-being. So again, we want to make a distinction between the construct, the concept that we're interested in, which is this sort of amorphous thing called well-being, versus our definition of how we measure it or how we operationalize the variable. Okay, so we're going to sort of shift gears a little bit here, and we're going to talk about our three types of claims that we can make. So there are three categories of research claims that can be made about the world. The first are frequency claims. The second are association claims. And the third are causal claims. We're going to go through each of these in turn and define them, but so that we have a little bit of an idea going into it, let's look at some examples over here on the right. So if I claimed that 4 in 10 teenagers admit to texting while driving, that's a frequency, right? 40%, or 4 in 10 teenagers text while they drive or admit to texting while they drive. It is a singular claim about a single variable, texting and driving, and its frequency of occurrence in the population. Association claims are claims where we link two variables together. So single people eat fewer vegetables. We have two variables here. We have relationship status, right? Single versus in a relationship. And then we have variable number 2, which is the quantity of vegetables that you consume. And we're making a claim that links both of these variables together. We're claiming that relationship status is associated with quantity of vegetables consumed. Now, notice that we're just making a claim that they're associated. We're not saying that being single causes you to eat fewer vegetables. We're just saying that single people do eat fewer vegetables. We're not yet making a claim of active direct causation. And of course, our third type of claim are causal claims, those that make active direct claims of causality. So music lessons enhance your IQ. Right? Taking music lessons will raise your IQ. Family meals curb eating disorders. Right? The more family meals you have, it will cause you to have fewer eating disorders. So let's look at frequency claims first. Frequency claims describe a rate or degree of one variable. So if you're trying to identify a frequency claims are those that only include one variable. And in particular, that variable is always going to be a measured variable. So our example here, 4 in 10 teens admit to texting while driving. There's one variable, right? Texting while driving. And we're simply discussing its rate. Here are some other frequency claims. 70% of Atlanta residents use public transit. Oftentimes, you'll see frequency claims as rates, percentages, or proportions. 1 in 30 people use a flip phone. 2/3 of psychology majors are women. 52% of Americans are college graduates. These are all simply claims about the rate of occurrence of a particular variable. I completely made all of these up. I don't know if they're true. I think the psychology major one is pretty close to true based on the last data I actually saw on that. In undergrad, 2/3 of psychology majors are women. I believe that's pretty close to the actual rate. Okay. Let's look at association claims. Association claims argue that one level of the variable is likely to be associated with a particular level of another variable. So you can think of it as one variable changes, it is related to the change in the other variable, right? They're in synchrony somehow, right? Association claims involve at least 2 measured variables. They can involve more, but we're going to stick to just two variables for now. We'll get to 3 or more variables much later in the semester. When variables are actually associated with each other, they are said to correlate. Correlate is a very specific statistical term. You'll often see that word used just to mean a relationship in the real world. But in the world of statistics, we actually conduct a correlation test. There's a statistic called a correlation that we're going to learn actually this semester how to calculate. And it's the way that we quantify the level of association between 2 variables. So, for example, shy people are more accurate at reading facial expressions. Let's just say. So variable 1 is your amount of shyness, right? People will vary from high to low on how shy they are, and I can measure where they fall on that variable. Versus variable 2, which is accuracy of reading facial expressions. Some people are going to be good at reading facial expressions. Some people are going to be bad at reading facial expressions. And what I'm claiming is that one of those variables can predict the other one. It doesn't matter which way you go in an association. I could say that your degree of shyness will predict your accuracy of facial expressions, or I could do the opposite. And I could say your accuracy of facial expressions will predict your quantity of shyness. Doesn't matter which direction you go. It's bidirectional for association claims. These claims will vary in strength and directionality. We're going to talk about that here in the upcoming slides. And we quantify their strength and directionality using the statistic known as a correlation. A couple more examples. People who smile more have higher vocabularies. People who sleep more are better at problem-solving abilities or have better problem-solving abilities. The more bacon you eat, the more likely you are to have heart disease. Right? That one seems true, but I just kind of made all these up as well. Notice 2 variables. We can measure each of them, and we're just claiming that they have a relationship. We don't know what's causing what yet. So as we're quantifying the degree and direction of a correlation, we can sort of imagine. I find it easy to visualize these relationships in order to sort of imagine their properties. So here we have what's known as a scatter plot, where we have our 2 variables listed on one of them on the y-axis, one of them on the x-axis. On the x-axis here, we have amount of expressed gratitude to your partner. And on the y-axis, we have relationship longevity. We call this a positive association because as amount of expressed gratitude increases, relationship longevity tends to increase as well. Or you could say it the opposite: as gratitude decreases, relationship longevity tends to decrease. Positive correlations will have a general trend of where the data sort of look like they're moving from the bottom left to the top right. If we were to draw a line of best fit, we would draw it in this direction, right where my sort of laser pointer is tracing. If we were to draw a line of best fit, it would look like this. And that line is sort of our average relationship. It describes the relationship such that as you're increasing on one variable, on average, you're increasing on the other variable. Or the same thing, just said in the opposite direction. As you're decreasing on one of the variables, on average, you're decreasing in the other variable. So we call those positive correlations. Then the opposite relationship is a negative correlation. So negative correlations have a line of best fit that moves from the top left to the bottom right of our scatter plot. Right? So it's like this instead of like this. Right? They're positive versus negative correlations. The lines of best fit move in opposite directions from one another. And in a negative association, we have an inverse relationship between our variables, such that as one of them increases in value, the other one decreases in value. They move opposite of one another. They don't move together. Notice how in a positive association, as one goes up, the other goes up, right? As one goes down, the other goes down. They're sort of, they move together in synchrony, versus a negative association where the variables move in an inverse relationship with one another, whereas one variable increases, the other decreases. So how frequently do you multitask versus how good you are at multitasking, right? Whatever. Doesn't matter what the example is. The more you multitask, right? People who multitask more often are being found to be less skilled at multitasking. So as frequency of multitasking goes up, skill of multitasking is going down. Right? They're moving in opposite directions. This is an inverse relationship, and we call it a negative correlation or a negative association. And of course, just because you measure two variables doesn't mean that they are going to have a relationship. They might have no association with one another. When we visualize a non-existent association or correlation, it looks like you just took rocks and threw them up on a wall, right? Or you shot a shotgun into some drywall, right? It's just this random spread of dots. There's seemingly no pattern or relationship between these two variables. Here we have how early versus how late you eat dinner, and then the weight of, the weight of the children in that family or something like that. And so we can see that it doesn't matter whether you eat dinner early or late or sometime in the middle. There's really no predictive ability about whether a child will be more or less obese, right? These variables don't do anything for each other. There's just no relationship. So we're not going to learn how to calculate a correlation yet, but we do need to know how maybe to interpret them at this point. So when we calculate a correlation statistic, the value of that statistic ranges from -1 to +1. That's it. Correlations will never be beyond 1.0 or -1.0. The closer to zero, so the closer to the 0 point of a correlation, the weaker the association is. And then as we move out from zero in either direction, the strength of the relationship increases. So the absolute value of a correlation tells us its strength. the positive or negative sign of the correlation tells us its directionality, whether it's a positive or a negative correlation. So in our zero association, this would be, if we were to actually calculate correlation for these data, it would be around zero, maybe 0.05 or negative 0.05, something like that. Very, very small, very, very close to zero. Here we have a moderately strong negative correlation. This might be a correlation of like negative 0.5 or negative 0.6, something like that. And it's negative because of its directionality. Right? We know it's negative because it has an inverse relationship. Versus this positive correlation, this is a bit of a weaker positive correlation because there's some sort of ambiguity, there's some spread, there's some messiness in the data. So maybe this is a positive correlation of 0.3, 0.35, maybe 0.4, something like that. Again, don't worry about how to calculate that number. All you need to worry about is how to interpret that number. So a correlation of positive 0.90 would be a very strong positive correlation. It means these variables move together and they do so almost perfectly, right? There's a very tight relationship between as one variable goes up, the other one goes up with it. As one variable goes down, the other one comes down with it. Right? 0.9. That's almost as strong as you can get, right? 1.0 would be the strongest correlation. But the same thing on the negative side. Negative 0.90 is a strong negative correlation. So don't think that the positive or the negative has anything to do with the strength of the relationship. Positive or negative has to do with the directionality of the relationship, right? Which way our line of best fit goes, whether it's they're in synchrony or whether they are inverse. So the sign tells us the directionality. The absolute value tells us the strength. So correlations are great. Association claims are great. Let's backtrack. That's what we're talking about here, right? We're talking about how to quantify association claims. They're good. We make a lot of them. And a lot of the research that you will see and read about in the world are association claims and correlations. However, there are some limitations to them. We cannot draw causal conclusions from correlation claims because there could be some confounding third variable. Right? If we remember that idea from chapter 1, there could always be a confounding third variable influencing the relationship that might create the illusion of a relationship, but there's not actually a causal relationship. So, for example, there is a positive correlation, a real, actual, identifiable positive correlation between how much ice cream is sold in an area and that area's crime rate, such that as ice cream sales increase, crime rates increase. As ice cream sales decrease, crime rates decrease. That's a real relationship. We find that in the world. It would be silly of us to claim that people eating ice cream causes them to commit crimes. It would also be silly for us to claim that committing crimes causes people to eat ice cream. The causal nature here doesn't make any sense. It's just an association, because what's actually going on is that there's a third variable out there in the world, and that's temperature. And temperature is what actually causes this relationship. As temperature increases, right, it becomes like spring and summer, people buy more ice cream, right? You eat ice cream in the summer. And people also commit more crimes in the summer. In fact, if you look at just human activity in general, when it's warmer, there's more human activity. people are more likely to go out, right? You go out to a park, you go out and you sit outside and you have coffee or a beer or lunch with your friends. You go on vacation, right? You move around just physically more often when the temperature is higher. And one component of human activity and human movement is crime. People are more likely to commit crimes in the summer. People are less likely to commit crimes in the winter because it's cold and people don't like to go outside and do things, right? You hunker down and you make hot chocolate and you snuggle with a blanket and you read a good book, right? That's what you do in the winter. You don't go out and do things. And we actually see crime rates fall in the winter. It's what I call it's difficult to steal a car in the snow, right? There's just less crime because there's less human activity, and there's also less ice cream sold in the winter. So these two variables that have an association, ice cream and crime, they have a real association. We can calculate the correlation coefficient between those two variables. It might be something like 0.4, 0.5. But just because they are related to one another does not mean that one of them is causing the other one. There's a difference between saying things have a relationship, which is an association claim, and then claiming that things cause each other, which is a causal claim. Some goofy examples of why we don't want to mistakenly turn an association claim into a causal claim. These are real data that I've pulled from various sources and figures. The black line is suicides in the United States by hanging, strangulation, and suffocation. And the red line is how much the United States spends on science, space, and technology from the decade 1999 to 2009. And we can see that these two variables are related to one another. They move together. As spending on science increased over time, so did suicides by hanging, strangulation, and suffocation. It doesn't mean that one of them causes the other one, right? It would be silly for us to say, well, there's people hanging themselves because of all the money we're spending on science, right? They're not causing one another. They're just related to one another. They have a relationship. But it's very unlikely that these two variables are actually impacting each other directly in a causal manner. Sorry, that's a little fuzzy. Must have had to blow that up. It was probably too small. But anyway, we can see the variables. The red line is the number of people or the rate of divorce in Maine. We can see that it has fallen over time. And so has per capita consumption of margarine. It's also fallen over time. But that doesn't mean that these two things have anything to do with each other. Right? They're correlated, but they are not causally related. So we like association claims. They're useful because they help us make predictions. And the stronger the association or the stronger the correlation coefficient between two variables, the more accurate that prediction will be, the better predictor it will be. Both positive and negative associations can help us make predictions, but obviously a zero association or a weak association or a correlation coefficient around zero doesn't help us, right? That's what that means. It means they're non-predictive. They don't have a relationship. And lastly, causal claims. Causal claims are those where we explicitly state that one variable causes another variable to occur or change. Causal claims can have multiple either measured variables and multiple manipulated variables, but we must have at least one of each. We have to have at least one manipulated variable and at least one measured variable. And if you do, then you have an experiment. That's what we call an experiment, when we manipulate a variable and then we measure its outcome. Association claims, so single people eat fewer vegetables, are research claims but they are not experimental claims. Because if I just went out and let's say I surveyed 1,000 people and I asked them, are you single or are you in a relationship? Right? I'm just measuring something. So that's a measured variable. And then how many servings of vegetables do you eat a day or a week? Right? I'm just measuring how many vegetables they eat. That's two measured variables that I'm claiming are associated with one another. But I didn't manipulate anything in the world. So in this case, I have done research, but I have not done an experiment. An experiment requires the researcher to actively manipulate the world, such as music lessons enhance IQ. I have maybe 100 people take music lessons and I measure their IQ. I have 100 people maybe take sewing lessons, right? And then I measure their IQ and I compare the music lesson to the sewing lesson people, right? I the researcher, have actively manipulated the variable of lesson, right? Type of lesson. So that's a manipulated variable. And then I am measuring the outcome of IQ, which is my measured variable. So at least one measured and at least one manipulated variable. These answer questions like why or how. And we can sort of further complicate things by having experimental causal claims, which is what I just described with the music lessons versus sewing lessons, right? The researcher actively manipulates groups of people who either get music lessons or sewing lessons. Or I can engage in what's known as a quasi-experimental design. Quasi-experiments take advantage of naturally occurring variables that put people into distinct groups, but I can't manipulate people into those groups. So good examples of quasi-experimental designs, they use variables like gender or sexual orientation or race or religion or age. These are person-level variables typically that I cannot manipulate. I can't change your sexual orientation. I can't change how old you are. I can't change your race or your religion. That doesn't mean I can't ask research questions about those things. So I could measure what would be a good variable. GPA. I could look at male GPA versus female GPA, right? So I have two groups. It feels like an experiment because I have these two distinct groups of people. But notice that I didn't manipulate those groups. I can't force a group of people into the male group and force a group of people into the female group. They're naturally occurring person-level groups. I just take advantage of that natural occurrence. And so we call that a quasi-experimental design. It's sort of an experiment, but because I didn't technically manipulate anything, it's not fully an experiment. So a couple of research questions that would be fully experimental. How does drinking influence memory encoding? I could have a group of people who I force to drink a certain amount of alcohol, and I have a group of people who I force to remain sober, and then I compare them on their memory abilities or memory encoding. Does looking at cute babies increase caregiving? I could have a group of people that view cute babies, and I could have a group of people that don't, right? They view adults or they view animals or something else, right? And then I measure caregiving behaviors as my outcome. Okay. So again, this distinction between true experiments and quasi-experiments. True experiments manipulate an independent variable by randomly assigning participants to different experimental conditions or different levels of the variable into different, usually categories. Quasi-experimental designs are unable to randomly assign people because quasi-experimental designs take advantage of naturally occurring variables which either cannot be or cannot ethically be manipulated. So for example, some variables that you could take advantage of for quasi-experimental designs, things like gender, relationship status, cancer diagnosis, right? I can't I can't give someone cancer, or I can't manipulate whether someone has cancer or not. But that might be something I want to study, is how those with cancer versus not with cancer, fare on some outcome. Brain damage. This one was used a lot across the course of psychology. You can't ethically damage someone's brain in order to study them, but you can take advantage of naturally occurring brain trauma, right? So we could look at the big one now is CTE in NFL players in particular, but athletes of all kinds are getting symptoms of CTE from repeated head trauma, right? I can't force someone to engage in head trauma, but I can take advantage of people who experience head trauma naturally based on their own choices. And then I can do a quasi experiment. Okay, so here we have some examples. I'm sorry. Let's say that I want to study long-term relationship satisfaction. I want you to take a minute and maybe press pause again and come up with one or two examples of a true experiment you could do where you manipulate a variable that you think will matter or change long-term relationship satisfaction. And then I want you to think of an example or two of a quasi-experimental variable, so a naturally occurring variable that you cannot manipulate, but that you can take advantage of to study its effect on long-term relationship satisfaction. So press pause, come up with one or two examples of each, then press play, and I'll give you a couple examples. Okay, hope you're back. True experiments. I mean, there's literally hundreds of these that you could do. We could manipulate the occurrence of a shared activity, right? So we create situations where some of our participants engage in a shared activity with their relationship partner, like a puzzle or a game, right, or a problem solving, whatever. And then the other people do not engage in a sort of mutual task. We could manipulate things like frequency of sexual intercourse, right? So we could force let's say we have 100 couples. We force half of them to only have sex, once a week, and that we force the other half to have sex 3 times a week, and we study the impact that has on long-term relationships, right? And that could be feasible. So any variable that you could actively manipulate ethically can become a true experiment. Quasi experiments, again, a little easier. We could take advantage of things like race, ethnicity, nationality, gender, anything like that to make comparisons across long-term relationship satisfaction. Okay. Oftentimes when you see a claim in the popular press, it can be difficult to ascertain whether it's an association or a causal claim. Frequency claims are easy to identify, but association versus causal claims are not as easy to identify. And so this is not an exhaustive list, but this is a pretty good list of language that you might see used to describe an association claim versus language that describes a causal claim. So linked to, higher risk, correlated with, prefer, may predict, goes with, is tied to. That sort of soft language is an association claim typically. Causal claims use more direct, harder language like increases, decreases, reduces, promotes, affects, exacerbates, changes, leads to, right? This is language that makes a hard claim about causing something else. Okay, so quickly, let's practice identifying our 3 types of claims. Press pause on your video. and see if you can determine whether each of these claims is frequency, association, or causal. So press pause and choose for each of these claims either frequency, association, or causal. All right, I hope you're back. Let's go through them. 30% of seniors have dementia. That's a frequency claim, right? One variable, frequency of dementia, rate of dementia. That's it. Breastfeeding is linked to children's IQ. The key term here is linked. That's soft language. That's an association claim. Cursing is related to higher intelligence. Related to is, again, some more soft language. That's an association claim. Meditation results in lower cortisol levels. That is a harsh, hard causal claim. People who smoke are at higher risk for depression. At higher risk for is, again, a soft claim. That's an association. 1 out of 700 Americans don't know how to read. That is a frequency claim, right? It's just a rate, a percentage about a single variable. Okay, that's it for part 1. We will pick it up with part 2, where we'll finish the chapter and discuss, now that we've identified the types of claims and what goes into them, how can we evaluate a claim? How do we decide whether a claim is a legitimate or a good claim, a worthwhile claim that we maybe want to support, versus identifying claims where maybe we want to withhold our support, or this claim doesn't have as much support or sort of oomph behind it as we would like it to. We do that using our 4 validities. So we'll discuss that in part 2. Thanks for watching, and I will see you next time.